Hello friends, welcome to our channel study guide. As you know, we are providing the SSC JEE 2018 solved paper of 23rd of January 2018 second shift paper. Okay, and all this solution we are not using any calculator. If you haven't seen already the three of the previous sessions, okay, you can go to our description and we have given the link over there, the videos of the previous three videos. Okay, so let us start the fourth session. Okay, we have already solved all these questions. We will start from 920. Okay, so what did the question says here? Determine the value of current through the 10 ohm resistor. So what do we have to calculate? Okay, let us see through our digital pen. So here it is said that 10 ohm, okay, 10 ohm resistor, if a source of 8 volt with internal resistance of 1 ohm is connected at PQ terminal, so PQ terminal with a positive terminal at P, so there should be the positive at the P and negative at the Q. Now it should have an internal resistance of 1 ohm that is connected in series. Okay, so this is our actual figure of the problem. Now what do we have to do? We have to find the current through the 10 ohm resistance. So what is the value of the 10 ohm resistance? That is, let us suppose this is the current I. Okay, so here we are very interested to solve it by superposition theorem. Okay, so in superposition theorem, here we have two source, one voltage source of 8 volt and one current source of 3 ampere. So first let us take the 8 volt source first. So if I take the 8 volt source first, then what will happen? This is our equivalent circuit. The 3 ampere will be open. Okay, this is the 1 ohm and this is the 8 volt. Okay, so we have to use the eraser over here. Now this is the 8 volt. Now this is the 5, this is 5 and this is 10. Okay, this is 5, this is 5 and this is 10. Now how can we calculate the current very easily? Okay, so first we have to think what is the equivalent circuit of this one. The equivalent circuit will be like this one. There will be a 10 ohm, so 10 resistance and 10 ohm resistance are connected in parallel, and here this is the 10 and this is the 10 and this is 1 and this is 8 volt. Okay, now this is 10, this is 10, this is 1 ohm. Now what will happen? They are 10 ohm and 10 ohm are in parallel. So what I can say that the equivalent will be like this one, 1 5 8 volt. Okay, so if you ask that what is the current through the 10 ohm, where is the 10 ohm? 10 ohm is gone already. So first let us calculate the total current of the circuit. This is the total current. Okay, this is the total current of the circuit. This is I, that will be total voltage 8 volt by total resistance 5 plus 1 6. Okay, because in this path no current will flow because open circuit. Now here we can see it by the highlighter pen. Now in this path, okay, in this path what is the current? The current is 8 by 6, that is 4 by 3. The current is 4 by 3 or 8 by 6. Now this current has come to this junction and divided into two part. The two part has same resistance of 10 ohm. So what we can say, that the current will be that the resistance will be divided in two parts. So the I 10 ohm will be 4 by 3 divided by 2. 4 by 3 divided by 2. That means 4 by 6. 4 by 3 divided by 2, that means 4 by 6. Now if I divide it by 2, that means 2 by 3. Okay, so I through 10 ohm 2 by 3 for only the 8 volt source. This is our step 1, not our step 2. In the step 2 we will take the 3 ampere. Okay, in our step 1 we have take only the 8 volt. What we have done, again I am repeating once again, it is said that 8 volt source is connected with the 1 ohm resistance connected in series with the 10 ohm that is connected with the 5 ohm and 5 ohm. Current source will be open circuit for the first step 1. Now 5 ohm and 5 ohm are connected in series, okay, because the current which will enter, okay, let's say see by the highlighter pen, this current which will enter from this part that will move this part, okay, so there will be no parallel branch of the current. So this is the series circuit. So what we can write, that there is a 10 ohm and it is also 10 ohm, okay, so both are to 10 ohms. If 10 ohm and 10 ohms are parallel, that means they are 5 ohm, okay. Now total circuit resistance 1 plus 5, that will be the 6 ohm. Now what will the current, total current will be total voltage 8 volt by total resistance 6 ohm. So V by I, that will be 4 by V by I, that is will be 4 by 3. Now the total current is 4 by 3. This current is divided at this junction is divided into two parts, in this 10 ohm and in this 10 ohm. If it is divided into two parts, then what will happen, it will be divided in by the two parts, that will be half, that is 4 by 3 divided by 2, that will be 2 by 3, that will be 2 by 3 ampere. Now this is the current only for the 10 ohm, okay, for the 10 ohm resistance. This is the current through the 10 ohm resistance only for the 8 volt source. Now we are also interested about the 3 ampere source, because we have to calculate according to the superposition theorem, we have to calculate each and every source, okay. So let us move to the our next slide. Okay, in this slide we are interested in the 3 ampere source. Now the 3 ampere source is like this one. This is the 3 ampere source, okay. This is 5 ohm, this is 5 ohm, this is 10 ohm, okay, and this is 1 ohm, okay. Now 1 ohm is in parallel and we have already shorted the voltage, okay. This is 5, this is 5, okay. So what is the equivalent, okay, and the next step what we can write over here, we can write 5, this is 5, okay, this is 10 by 11, right, 10 by 11, because 10 and 1 parallel, 10 into 1 by 10 plus 1, that is 10 by 1. This is 5 and this is 5 and this is 3 ampere. Now we are very interested to find the first, we have to find this current of this branch, okay. If I can find the current of this branch, then what I can do, I can find this current of this branch at this junction. The current is divided in two parts, okay. If the current is divided into two parts, then what will happen, we can easily find the current through the 10 ohm resistance, okay. So first let us use the current division rule. What is the current division rule says? Now this is a 3 ampere, this 3 ampere current is going and it is divided into two parts, okay, 5 ohm and 5 ohm and 10 by 11. Now you can see that there is a one point, common point. So this current is not divided, this current is series circuit, so current through this branch is same. So here I can say that 5 and 10 by 11, these two resistance are in series, and this branch, okay, by the highlighter pen, this branch is parallel to the 5 ohm, this branch is parallel to the 5 ohm. Now what is the current division rule says? Current division rule is opposite side resistance. What is the opposite side resistance? That is the opposite side resistance is the 5 ohm, this 5 ohm 1, and the total resistance is 5 ohm plus 5 ohm plus 10 by 11 ohm. Now if I can simplify it, what I have to do, I have to multiply it by the 11 on the both numerator and denominator, because I can see a 11 over there. So 11 into 5 55, 11 into 5 55 plus 5 into 11 55 plus 10. Now the finally it comes 3 into 55 by 120, 55 by 120. Very simple calculation. So we have already calculated the current of this branch, okay, this branch current we have already calculated. Now this current is again dividing into two parts, so again there is a current division rule. The total current is 3 multiplied by 55 by 120 into opposite side resistance. What is the opposite side resistance? Is opposite side resistance is 10, opposite side resistance is 10, okay. Sorry, we have to calculate the 10 ohm current through the 10 ohm resistance. If we have to calculate the current through 10 ohm resistance, the opposite side resistance will be the 1 ohm, okay. Opposite side resistance will be the 1 ohm, okay. Whichever resistance we want to calculate, we have to take the resistance on the numerator, the opposite side. Opposite side is 1, so total is 1 plus 10, 11. Now 3 multiplied by 55 by 120 into 1 upon 11. So 11, 5, 3, 45, 8. So it will become 1 upon 8, and this current is downward. Okay, in the first step 1, the current is downward, and here it is also downward. So what is the total current? In the first step, we have already found what is the current value of 2 by 3. What is the value of 2 by 3? 2 by 3 means 0.666, right? Okay, and 1 by 8 means we already know 0.125. No need to use the calculator. Okay, no need to use the calculator. Okay, where is our pen? Okay, just a second. Okay, so if I multiply it, we find that 0, 6 plus 5, 1, 3, 9, 0, 7, 9, 1. Okay, if you get the options, okay, go through the options. 0.79, 0.43, 0.45, and 0.64. So these are the 4 options. Okay, if these are the 4 options, then what will happen? The correct answer will be, the nearest correct answer will be 0.79. Okay, we have applied a superposition theorem. In the step 1, we have used the voltage source. In the step 2, we have used the current source and the current division rule, of course. Okay, so I hope that this problem is very easy, and it can be solved with the calculator in the examination hall too. Okay, if your calculation is very fast, you can do it in very few moments. Okay, as I have to clearly state all the steps, so it needs time, but in your exam you have no need to explanation to anyone. Okay, just do your calculation, very simple calculation, and make it very fast in the question paper. Okay, so moving to the next question. Which one of the following in the SI unit of the magnetic field strength? Magnetic field strength, what is the unit of the magnetic field strength? That is AT per m. AT unit is AT per m. Now what is AT? A is the ampere and T is turns. Turns has no unit. Okay, so ampere per meter. Okay, so this is equivalent to ampere per meter. This is the, so option 4 is the correct answer. But we should know about all the other 3 options. Weber is the unit of SI unit of magnetic flux. Tesla is the SI unit of magnetic flux density. Now what is ampere into meter? Now we know that I is equals to Q upon T. Okay, so what is Q? Q is equals to I into T. So this is ampere and this is, okay, T is the time, ampere into second. Okay, this is not ampere into second, so this one open. Okay, so ampere per meter will be the correct answer. Okay, next. There is a question on the discrepancy. Okay, so no correct answer been given by the commission, so we are moving to the next question. Which one of the following is the correct value of the magnetic permeability in the free space? What is the correct value of the magnetic permeability in the free space? That is 4 pi into 10 to the power minus 7 Henry per meter. Okay, and you should remember this value for the examination hall. The unit can be given in the Henry per meter or in the Weber per ampere into meter, or in the Weber per ampere into meter. Okay, so moving to the next question. If the magnetic susceptibility of any material, is less than 0, that means the negative, okay, then the material will be a diamagnetic material. Clearly remember it, very important question for the examination. It will be diamagnetic material, and the diamagnetic material example, this is bismuth, antimony, copper, zinc, mercury, gold, silver, etc. These all are the diamagnetic material, and they have a susceptance less than 0, that is a negative susceptance. Next, and this is our last question of this session. Determine the reluctance in ampere turns per Weber of a coil when the flux through the coil is 15 Weber and produced MMF of 30 ampere turns. Okay, what is reluctance? Now first let us write what is reluctance. Reluctance is the flux per, okay, sorry, reluctance will be mmf per flux. Okay, reluctance will be mmf per flux. mmf is a magnetomotive force and flux is a flux can be compared to the current. Okay, mmf can be compared to the emf. Okay, this formula comes from where the resistance is equals to emf by current. Okay, now what is the mmf given over here? Okay, mmf given here is 30. You can clearly see that 30 ampere turns, so 80. Now, and what is the flux given? Flux is given how much? 15 Weber. 15 Weber. So your answer comes to 80 per Weber. A very tricky question, very simple question. You can see the already your answer is given ampere turns per Weber. That means they are giving you how you will calculate this question in the examination. The trick already been given by them in the question. Okay, so there will be a lot of question in the examination which will the answer will be provided in the question 2. Okay, in the questions itself. Okay, so you should have a clear observation power. Okay, and thank you for the session. If you're watching our video, please subscribe to our channel and press the bell icon too for the next update. Okay, we will let us take some give some time and wait for the next session. Thank you.